So hello everyone, hope you're doing good and welcome back to my channel. I hope that you would have also done your best for the June Daily Leetcode Challenge because yesterday we completed the June Daily Leetcode Challenge. I know that I have some more videos to put for the June Daily Leetcode Challenge especially for the last 2 days, which we had hard questions. I meant to put videos for them, but I definitely hope that at least for the medium and easy level questions, you would have tried your best. And when you were in trouble, I hope my videos would have helped you. So with that expectation, I am going to continue with the Daily Leetcode Challenge. So my only suggestion to you will be like, please at least for the easy and medium level questions, because see, ultimately the fine companies ask the medium level questions which are on the slightly higher side, right? These are the ones you should target, and easy ones are for just beginners, and as well as like some of the tricks involved. They are also involved in easy level questions, so for that as well, right? So today is the day first for the July Daily Code Challenge, and please start it if you have not done till now. And if you are a new viewer, definitely I expect you to like at least be aware of what's happening here, what is lead code and why coding is that important. And if you are in a first 4 years of like your career, that is your graduation or any degree if you are doing, then why coding is important for you, especially before the final year begins, right? These are some of the things which I wanted to make you aware of so that you understand what is the importance of this. Okay. So with this, we are going to continue for the July Little Code Challenge. Even if you have not maintained your pace till now, please try to do it now, at least from now onwards, right? So today is the first question of July Daily Code Challenge, and let's see what the question is. It's question 2305, fair distribution of cookies. Okay. So we are given two inputs basically. K is a integer, and this cookies is a array of integers. Okay. So what it represents that C. Each thing here, for example, this thing represents the number of cookies in the zeroth bag. Okay, this represents the number of cookies in the first bag, this represents number of cookies in the second bag, and so on. Okay, and this represents number of children. Okay, what we have to do is we have to distribute these bags among these children. Okay, such that there is a fair distribution. Okay, then they have given us a way to calculate the fairness, and ultimately the question revolves around that. Okay, we'll see the question and the words given in the question, and then we'll come to the example one. Okay, what they're given is we are given integer array cookies where cookies of I denotes the number of cookies in the ith bag. As I mentioned, see, for example, this thing, this now is there are 10 cookies in the second bag. Okay, because this is the second index of the cookies array, right? So it tells that there are 10 cookies in the second bag. Okay, you are also given integer k that denotes the number of children to distribute all the bags of cookies. Okay. So this tells that I have only two children present to whom I am going to distribute all the six bags here. Okay. All the six bags here. Okay. All the cookies in the bag must go to the same children, and that was the time to say is, for example, in the first bag I have 15 cookies. Okay. So all the 15 cookies, that is the whole bag with whatever content it has, should go to only one of the children. Okay. We cannot split the content of a bag among children. Okay, that's the basic idea. It should go as a whole to only one children. Okay, so now comes the actual part of the question. They are now defining a term called unfairness here. Okay, the unfairness of a distribution is defined as the maximum total cookies obtained by children in this distribution. For example, see, suppose I give all of these cookies to only one children, then if I try to calculate the unfairness, unfairness is basically the maximum. Okay, see, for example, each children has got some amount, right? For example, first children has got a number of cookies, second children has got b number of cookies. So now I have to calculate the total, that is the maximum cookies that any children have got. Okay, so that will be like that will be what is called the unfairness. Okay, that will be what is called the unfairness. So I think by now you would have understood that we have to reduce this parameter as much as possible. Okay, unfairness should be reduced as much as possible. That's what the question is. Return the minimum unfairness of all distributions. Okay. So what is unfairness? Unfairness is basically the maximum total cookies obtained by a child in that particular distribution. Please write this point somewhere, or at least maintain a notepad whenever you solve such a question. Because see, um, see, even in the interview, I expect you to do this. Whenever these terms are being, see, obviously, in interview will not get a written questions like this. Okay, either they will tell you verbally, or you will be just given the inputs. Okay, so please make a note of these things because it will help you to negotiate with the interviewer. Okay, whatever is the important terms, especially terms like this, please note it down in a notepad or type it. Then it will be easier for you to understand, as well as for the interviewer, he can check whether you are understanding it correctly or not, right? So these are some of the important things. So unfairness is basically the maximum total of cookies obtained by any one child in the distribution. Okay, ultimate goal is to reduce the unfairness. We have to find the minimum unfairness of all distributions. Okay, so we'll see quickly the example, then only it will be very clear. Okay, so these are the number of cookies. Okay, there are six bags basically, and then there are two children to be distributed. Okay, so what we are doing is, see, we are giving these many cookies, sorry, 8, 15, and 10. Okay, 8, 15, and 8 again. Okay, these are the ones, this we are going to give to the first child. Okay, so that total becomes 31. Similarly, for the second child, we'll give the remaining ones. Okay, so the total becomes 30. Okay, and now out of 30 and 31, the maximum is 31, right? So the unfairness of this case becomes 31. Okay, so the unfairness of this particular distribution becomes 31, and they are telling that it can be shown that there is no distribution with an unfairness less than 31. So the minimum possible answer in this case is going to be 31. Okay, that's what they are claiming. Okay, we are not going to verify why it's like that, but they are just claiming it. Okay, we have seen this as an example, right? So the idea here is, in all you have to take any approach possible such that you get all the distributions. You have to calculate the maximum number of cookies obtained by a child in all the distributions, and then you have to take the minimum of that. Okay, that is what the question is. There are some more examples given, but I think once you understand what's the logic, I think there's no more need to go for other examples. Okay, first example is enough for you to understand. One more important thing which I want to highlight is, see, these things where make a lot of difference. Okay, if this thing is not given, maybe the answer will not be valid. Okay, so they've clearly mentioned that k is always going to be less than or equal to cookies dot length. What it means is, there will never, see, for example, if you try to take the distribution which is going to be our answer, in that distribution there will never be a case that any one children goes without a cookie. Okay, please try to make it very clear. K is less than equal to cookies dot length. What it means is number of bags. Okay, cookies basically means number of bags, right? See, cookies array is basically number of bags, right? If you take the length of the cookies array, it basically depends number of bags, right? So there will never be a case where where the distribution which is going to contribute for the answer is such that any children is without a bag. Okay, so that will never happen, because k is always going to less than equal to number of cookies. Okay, sorry, number of bags. If k is greater than equal to number of bags, then definitely there will be at least one children. Okay, definitely there are real chances that there will be children which without any bag. Okay, so they will have zero. So one thing is very clear. See, this condition also I'm going to use in my calculations, because this will avoid a lot of you know the cases, a lot of permutation combinations which we are going to avoid because of this. Okay, so the idea here is the answer. Okay, that is the distribution which is going to be the contributing for the answer, that will never have a children without a bag. Okay, please make this one very very clear. For example, there are three children for which the distribution is not done yet. That means there should be at least three bags remaining. Okay, which we are yet to allocate. Otherwise, we that particular solution, whether that particular common combination is not going to contribute for the answer. As simple as that. So please highlight this point. After end of this video, I'm definitely sure that this is the only part of the question which requires some attention. Other things are going to be very simple. Please highlight this part. If you have any doubt in the question after I close this video, please come to this part and see, because of this I'm going to write this part of the code. Okay, I'm highlighting it very very clearly in the starting itself. Now let us come to the code. Let me be very frank here. They are going to, see, this approach is going to be, see, it's the brute force approach. Okay, we are going to use backtracking, something called backtracking, and backtracking in the most raw form. Okay, that is in a brute force approach. Okay, if you talk about the time complexity of it, see, I will tell you how the time complexity is coming. See, there are n number of cookies, let us say. Okay, n number of cookies. Okay, each cookie can go to any of the k children. Okay, each cookie can go to any of the k children. Okay, that means if n is the number of bags, then the time complexity of this solution is going to be k raised to the power n. Okay, k power n. Okay, k comma n. Okay, k raised to the power n is going to be the time complexity of this solution. Okay, as I like that, as I mentioned, see, suppose this length is n. Okay, each of these bags, okay, each of these bags can go to any of any one of the k children. Okay, so it has eight possibilities. Similarly, this also has eight possibilities. Sorry, k possibilities. This also has k possibilities, and so on. So k multiplied with the number length of this array, so it is going to be k raised to power n. Okay, that's the time complexity. Now coming to the solution, see, is going to be the backtracking approach. You will see the answer. Okay, so this is the answer. See, they are telling minimum. Okay, that's why I am taking the maximum possible value here first. Okay, so float of infinite. See, remember, these things will help you a lot in interviews. Okay, especially in programming rounds. I am taking the maximum possible floating point value. In Python, it's called float of infinite. Okay, float in brackets INF. Okay, then I'm taking the length of the bags. That is, n represents the total number of bags. Okay, now there is some function here. I will come to this later. But just remember, see, the idea here is, see, I will tell me the ith index, see, I will be among one among these. Okay, I will be one among these. Okay, I will tell me which, for example, see what will do is I will go to 8. Okay, I will go to this particular bag, then I will distribute it to all of the k children one by one. Okay, all of the children one by one. For example, in the first case, I will distribute it to k equal to 1. Okay, then in the second case, I will distribute to k equal to 2. Okay, then I will come to this bag. This bag again, I will going to distribute to the children. Okay, so you can just see this diagram here. Okay, this is what we are going to do. See, first I will get to the cookie 0 to child 0, then cookie 0 to child 1, cookie 0 to child 2, and so on. It will be happening. Okay, that's what I'm going to do. I'm taking inspiration from the same approach. Okay, that's what I'm going to do. And then when we come to cookie 10, this also the same way possible. I will distribute each of the bits. So let us see how it's being done. So I represent the index which we are going to distribute. It's one of the indexes of the cookie array which I'm going to distribute. Okay, ith one is going to be distributed in this loop. Okay, in the ith loop. Now comes the array part. What is this ARR? Okay, ARR basically represents the array. Okay, basically tells the allocation. Okay, for example, this ARR is of length k. Okay, because there are k children, so it is also of length k. It will tell me, for example, the zeroth index of it refers to the zero child, how many cookies he has got. The first index of it refers to the first child, how many cookies he has got, and so on. Okay, that's the basic idea. So how is the function called being made for the first time? See, I am passing 0, that is the zeroth cookie is to be distributed. Okay, then I am passing a array of length k with all zeros, because in the when we begin this loop, what will happen is the none of the children will have any cookies, any bags, so we'll have 0 there. Okay, we'll have 0 there. It will have length k. Just remember these points. It will have length k because there are k children, and it will tell me the allocation. Initially, all of them will have 0 bags or cookies, whatever you call it. So all of them will be 0 first. Okay, then we'll come here. Okay, these are some of the base ending conditions. We'll come to this later. Just avoid them for now. This is also edge case. Okay, we'll come to this later. Without that, also the solution should work. Okay, but this will help me reduce some of the extra calculations. Okay, we will also come to this later. But see, this is the most important part of the code. Okay, what I'm doing is, see, I am making j loop around 0 to k minus 1. Okay, what I'm doing is, in the jth array, that is this particular thing represents number of cookies with current, that is jth children have. Okay, jth children have this many cookies. Okay, so I am going to add the current cookie to that. Okay, ith cookie to that. Okay, then I am going to call it. Then I am going to go to the next index. Okay, that is I'm going to the I plus 1 index. Okay, once I return back, I'm going to subtract that cookie from it. Okay, so whatever I did here, basically, okay, I am canceling out here. Okay, I am canceling it out here. Okay. So that is the basic idea. What I'm doing is, see, first I have two children. Okay, what I will do is this I will add to the first children. Okay, then I will go to the I plus 1 index. What will happen is, then I will distribute this also. Okay, as you can see here, this is how it would progress. Okay, so zeroth cookie will give into zero child, zeroth cookie will give into first child, zeroth cookie will give into seventh child. Okay, then these cases will be explored further. Okay, then we will come to cookie one. Cookie one will be given to zero child, cookie one will give into child one, and cookie one will give into child one, and so on. Okay, so every case we are going to do like this. Okay, and after we come out of the C, because once you do this, okay, we'll come to this terminal conditions where the answer will be calculated and updated. Okay, once the answer is calculated and updated, no need to maintain that condition. Okay, that's why we'll remove that condition. Okay, remember we are doing a plus here, right? We are doing a plus here, and we are just subtracting again from it here. Okay, so what the idea is, see why it's brute force and backtracking approaches. Just try to understand what's happening here. First, talk about this. Okay, I have two children. Okay, I'll just trace it out here, because see, if I keep telling, it will be difficult for you to understand. Okay, initially I have two children, both of them will have 0. Okay, what will happen is this first thing will come. Okay, initially it will be given to this. Okay, this 0. Okay, the first child it will be given to this child, and in the other case, what will happen is it will be given to the second child. Okay, 0 comma 8. Okay, then we will move further. Okay, as you can see, this loop is being called, right? This function is being called. Okay, before these things are being changed, I am calling it for the I plus 1 index. Okay, so what will happen is I will go to the next index. Okay, what is the next index? Next index is 15. Okay, 15 now will we have two cases. Okay, either, so now 15 will have two cases. Okay, so what will happen? See, 15 will be either added to the first child, which is 15 plus 8. Okay, what is 15 plus 8? It's 23. 15 will be either added to the first child, or 15 will be added to the second child. Okay, what will happen? See, 8 will remain, and then 15 will come here. Okay, and similarly it will proceed further. Okay, now for this case also there will be two cases. Okay, when we come to the first item, okay, either 15 will go to the first child, or it will go to the second child. Okay, similarly, so these things will be calculated. Okay? For example, 0 comma 23 will come here, or the second case, 15 will come here. Okay, 15 comma 20, 15 comma 8. Okay, and this case will again be expanded. See, this is for the first. Okay, index 1. Okay, this comes for the index 1. Now this will be, index 2 also the same thing will happen. now index 2 is 10. Okay, so for each of these cases there will be two things: either 10 will be added to this or 10 will be added to this. Okay, similarly here also 10, either 10 will be added to this or 10 will be added to this, and it will be going on, so on it will be going on. Okay, so what will happen is, see, for till I minus 1 it will go on, right? When we come to the I equal to n, okay, we are going to stop the array, but before starting it we are going to calculate the answer. Okay, I'm going to take the max of the array. Okay, that is what they're telling us. This is the measure of unfairness. I'm going to take the max of the array. Okay, then I'm going to compare with the previous answer. Okay, whichever is the minimum, I'm going to take that. Okay, minimum of, okay, this thing or the previous answer. Okay, whichever is the minimum, I'm going to take that as answer. Remember, answer is initialized with maximum, that's a floating point maximum value. Okay, so whichever is the minimum, that will be taken as the answer. Okay, so I hope this code is clear to you now. I almost explained you everything except this. Okay, coming to this, they have clearly mentioned here, right? They've clearly mentioned here, definitely the number of children is going to be less than number of bags. Okay, less than or equal to number of bags. That means in the distribution which is going to contribute for the answer. Okay, see, there are many distributions, right? But only one of them is going to contribute for the answer. Okay, which is the most even distribution. Okay, let me say this: whichever is the most even distribution of bags, that will going to contribute for the answer, that will have the minimum unfairness. Okay, so what going to happen is, in that distribution, definitely each children will have at least one bag. Okay, each children will have at least one bag. There will never be a case where a children goes without bag, because ck is always going to be less than equal to cookies bags dot length. Okay, so I am going to take this as the condition. Every time I'm going to check if array dot count of zero. That means how many children are pending. Okay, how many children still have zero. That is how many children are without any bag still now. If that number is greater than n minus one. Okay, what is n minus? See, we are going for each index. Right, first index I'm going to distribute it among the children. Then comes second index, I'm going to distribute it among the children. Then third index I'm going to distribute it among the children. Okay, for example, I'm at this index. Okay, I'm at this index, so I have only two bags remaining. Okay, I have only two bags remaining. But if number of children without any bag is greater than two. Okay, if number of children without any bag is greater than two, that means that even distribution is not at all possible. Please try to understand this. I am at 10. Okay, I am at 10. That is I equal to 2. Okay, I is 2 here in this case. I have some distribution here. Okay, what will happen? I am at 10, right? So the see, this is coming from here. Okay, this I minus 1 means number of bags remaining to be distributed. Okay, there are two bags remaining to be distributed. Okay, two bags are remaining to be distributed, including the current bag. If you see, it's three bags. Okay, three bags are remaining to be distributed. If number of children without any bags. Okay, this is the code for that. Number of children without any bags. Okay, if the number of children without any bags is greater than 3, that means there are 4 or 5 children. Okay, whichever whatever way that it is, there are 4 or 5 children that is greater than any number greater than 3 without having any bags. So but we have only 3 bags remaining, right? So there will never be a case where we can give at least one bag to each of the children. Okay, there will definitely be one or more children without any bag. So we are going to stop there. We are not going to explore that situation further, explore that distribution further. That is the answer. I will again explain this. This is the only trickiest part. See, this tells me number of children without any bags. Okay, and this tells me how many bags are yet to be distributed. Okay, so if I'm at 10, that means I have 3 bags yet to be distributed, including 10. Okay, if I have 4 children without any bags, but there are only 3 bags to be distributed, then we cannot proceed with that solution, because see, even if we issue 3 bags to 3 children, definitely one children will go without any bag, right? And based on this condition, it's very clear that each children should have a bag. Okay, there should never be a case where children do not have a bag. Okay, that will definitely not control for the answer. So yeah, friends, that was all. Okay, if you want, I will just comment it out and I will give it to you. Okay, so that you can also understand the tracing part. Yeah. I think we have understood the time complexity at least by now. I'll just quickly run this and show you. Then I will again explain the time complexity. So yeah, you can see it's clear all test cases. So when it comes to time complexity, as I mentioned, see, this 8 can go to any number of children. This K8 can go to any one of the K children, right? This 15 can go to any one of the K children, right? So it has 8 ways. Okay, so this is K ways. This also is K ways. This also is K ways. So K into K into K. See, this is permutation combination. Okay, I learned in CBSE class 8. Right? This is what I'm applying here. So this is also K ways, right? So K into K into K, like this I have to do for n times. And that means K raised to power n. Okay, that means K raised to power n. Okay, that's what it is. That's going to be the time complexity of this. Please try to focus here. You will definitely understand what I'm doing. See, I always try to provide as many hints as possible, so that even the weakest student, okay, even someone who is not at all aware of what's coding and what's happening, you will at least get some hints of what's happening here. Okay, so I try to leave as many hints as possible. That's why I'm leaving these things in the. I will give this code in the comment. Please try to go this through once. Okay. After that, after you understand everything, after you trace it out, you definitely try to write it once or without seeing it. Okay. See, Why I leave these things is because, see, if you are in an interview, you have to do a dry run basically. Okay, see, I'm not saying full dry run or full length dry run. Okay, but at least the minimum part we have to show them, right? How it's working, how it's, how your thinking process is. So these things will help you a lot. Okay, please do these things if you are doing it alone on your own. Okay, what's happening, how, you have to graphically basically show in a pen and paper. In interview you will have the pen and paper or whiteboard, but if you are not having it, say, online interview, then you will have to type like this only in the interview itself. Okay? So often that was all for today. I hope I have started this July date channel with a lot of positivity. Please continue, and definitely one day will come when you will realize that you have made it right. So thanks a lot. See you tomorrow.